We're going to be looking at examples 5 and 6 in your section 3.2 notes. For these examples, we're going to use the sum and difference identities for tangent. I went ahead and wrote down the sum identity. So you take the tangent of the first plus the tangent of the second, and then you go ahead and take 1 minus the tangent of the first times the tangent of the second. If this happens to be a minus, all that happens is we get a minus on top and a plus on bottom. In other words, we switch signs. So that's exactly what's going to happen in this first example. Okay, and we're going to have tangent of 5 pi over 3, and then we're going to have minus the tangent of pi over 4. And in the denominator, we're going to have 1. Okay, and instead of having this minus sign, we're going to have a plus the tangent of 5 pi over 3 times the tangent of pi over 4. Okay. Now we need to evaluate. When I've already went ahead and drawn 5 pi over 3 in the fourth quadrant, its reference angle is pi over 3 or 60 degrees. So across from that, I put a negative root 3 since we're going down. Next to it is 1, and of course the hypotenuse is 2. Okay, so if I'm doing tangent here, then I'm going to have opposite over adjacent. So I'm just going to end up with negative root 3. Okay. Next up, I need to look at tangent of pi over 4, which I have the triangle drawn here. So again, tangent is opposite over adjacent, so we're just going to end up with a 1 over there. Okay, and then I'm going to have a 1, and then make sure I'm switching signs. I have a plus. Okay, we already found out that that was negative root 3, and this was a 1, so writing those in right like that. So we end up with negative root 3 minus 1. We really can't put that together. And then in the downstairs, we're going to have a 1, then a positive and a negative is going to make that a minus root 3. That's really good enough for me. Sometimes they also rationalize this by multiplying by the conjugate. So you could multiply the top and the denominator, the top and the bottom by 1 plus root 3. And get a little bit simpler answer by going through that. Okay, all right, let's move on to B. So B looks like the tangent sum identity because we have the plus upstairs and then we have the minus downstairs. So I recognize right off the bat that this is going to be the tangent of pi over 5 plus 4 pi over 5. So nicely enough, they have a common denominator, so I'll get 5 pi over 5, okay, which reduces to pi. So that's quadrantal, so I got to figure out what that means for me. So pi is over here, and the ordered pair from the unit circle is negative 1, 0, and I know I have cosine in the first spot and sine in the second spot. So if you remember the quotient identity for tangent, you're going to get sine divided by cosine. So I'm going to have 0 divided by negative 1. And of course, that leads us to the answer of 0. Okay, that does it for example 5. So now on to example 6. So we're going to start with the tangent difference identity. All right, so tangent difference identity is we take the tangent of the first angle minus the tangent of the second angle. So there's our top. And then we're going to take 1 plus the tangent of the first angle times the tangent of the second angle. Okay, so there's definitely a little evaluation to be done here. So this triangle here, we just looked at it in example 5. The tangent is 1. Okay, so I'm going to have 1 minus the tangent of x, and then 1 plus, well, 1 times the tangent of x is just going to leave me with tangent of x there. All right, so everything's in terms of tangent, but if we look at where we're heading, we need our answers to be in terms of cosines and sines. So we're going to use the quotient identity at this stage. Okay, so I'm substituting in, I'm going to have sine x over cosine x up there, and then I'm going to have sine x over cosine x downstairs. Okay, so we don't want to have a complex fraction, so one way to get rid of that is we can multiply the top and the bottom both by the cosine of x. That'll clear our fraction. We just need to make sure that we multiply it all the way through. So if I multiply it through here, I'm going to get the cosine of x. Okay, multiplying it here is making those terms cancel, so I'm just left with sine x. If I do the same thing downstairs, I'm going to have cosine of x when I multiply by 1. And once again, the canceling, so I'm going to have plus sine x. Okay, and that's actually was our goal. We wanted to get to that. So that completes example 6.